Hey everybody, we're the Bullpen Bros and you're watching our final demo video for our senior design project. My name is Matthew Strader and I'm a senior in electrical engineering.
My name is Sean Brennan. I'm also a senior in electrical engineering.
I'm John Osmond. I'm also a senior in electrical engineering.
I'm Derek Dervishian. I'm a senior in computer engineering. And this semester we have been developing a performance tracking system for baseball pitchers, and we will be showing you what we have all accomplished during this semester.
So the subsystem that I'll be talking about is the wearable subsystem, which is based on the ESP32 microcontroller. Coming off of the microcontroller, we have a heart rate sensor, an IMU, 3 LEDs, a push button, 2 push buttons, one for restart and then one to stop and start recording a session, and then finally a battery that is going to be a lithium polymer battery of 3.7 volts, and then that will all communicate to a Raspberry Pi via Bluetooth.
The subsystems that I primarily worked on this semester were the Bluetooth connectivity subsystem, which allowed the Raspberry Pi 4 and ESP32 microcontroller to communicate, the Raspberry Pi interfacing, as well as the arm path tracking and heart rate tracking algorithms.
For my part of the block diagram, I worked on the Python applications that were used to track the ball's trajectory as well as implement the strike zone and location of the pitch after the strike zone using the camera mount that was connected to the Raspberry Pi via USB to micro USB.
My primary responsibilities this semester are the green rectangles on the block diagram in front of you. The first one is using the video processing algorithm to track and determine the velocity and spin rate of the pitch thrown. The second one is taking all the data from the wearable and from the camera and displaying it on a user-friendly 7-inch LED touchscreen display. Before going on to the final demonstration, let's look over some of the requirements for our final design. The product must be able to provide actionable feedback that better equips organizations and their pitchers on how to regulate their pitching, improve their ability, and minimize the risk of injury. To do this, we must be able to measure the velocity and the spin rate of the ball, that's point 1 and 2. We must be able to determine if the ball or the pitch thrown is a ball or a strike. We'd also like to track the trajectory as the ball leaves the pitcher's hand and reaches home plate. The wearable device must also record the arm acceleration and the heart rate of the pitcher, and all this compiled data must be presented in a way that is reasonable and easy to understand for the onlooker. The Raspberry Pi and the ESP32 must be powered appropriately so that it can sustain power over the course of a normal workout, and all of this, of course, must be presented in a user-friendly, informative format.
First, we set up the camera by placing the tripod 8 feet behind and either 5 feet to the left for a righty or right for a lefty. The focal length should be set to 35 millimeters with the center of the viewfinder placed in the center of your target, or catcher, in order to place a strike zone correctly. Next, we plug the camera into the Raspberry Pi and LCD screen via micro USB.
To initiate the system, you click on the Python executable file. This will prompt a screen where you will be able to enter your device's MAC address. You must enter the MAC address of the correct format or else an error warning will appear. After you do that, your device will connect to the Raspberry Pi and the menu will pop up.
Now we're going to set up the wearable. To start off, we have a 3.7 lithium polymer battery, which is then powering the rest of the system. And it starts with turning on this blue switch here. We can see the green LED popped on, which means that there's system power. If we want to start a session as the user, we'd hold down this push button until the red light comes on. As soon as that comes on, that means that data is being sent to the Raspberry Pi. If we want to end the session, we simply hold down the LED again. If we want to turn off power, we can turn it off with the switch that we just turned on with. One last feature I'd like to show is the charging feature. So if we plug a USB into the USB connector here, we can see that the yellow light comes on, which means that the system is charging and that the battery is charging. If we were to take that out, then the system is solely powered by the battery and the charging light is no longer on. Now you're going to slip the wearable wristband onto your arm and then make sure that the heart rate sensor is attached like seen here.
So instead of a normal white baseball with red seams, we use this high visibility fluorescent yellowish green baseball because it's easier for our algorithm to detect. On top of that, you'll see that there are 2 black dots on either side. We use these to calculate the spin rate.
Now we're ready to start pitching. John will throw a pitch to Matt, and the data recorded by the camera and the wearable will be recorded and displayed on the LCD screen for viewer use.
So now let's take a look at what the Raspberry Pi sees. As you can see on the screen, John has delivered the pitch, and the Raspberry Pi is able to trace the ball through the air with that red line that you see on the screen. That trajectory is what ends up getting printed onto our user interface, and the velocity and the spin rate are also printed too. Some other things, such as temperature and heart rate, are captured by the wearable. Once this is done processing, you'll see the UI pop up on your screen. Okay, so now that John has delivered the pitch and the video has been processed, this user simply needs to come over and hit refresh. And as you can see, the workout time, the velocity, spin rate, and all of our gathered statistics are printed here on the UI. Now I'm going to hand it over to Derek, who's going to talk about the next pitch.
So now we'll throw another pitch to demonstrate the system's ability to overlay and record data for multiple pitches. Once again, after the pitch, the video shows the ball being traced for the user to see. Once the video finishes, it goes back to the UI again. After hitting refresh again, the numerical data gets updated and the graphical data gets updated to show the current and previous pitch data. After a workout, the user can export their data to a CSV file, which is currently being shown. The file is created with the current date and time so the user can differentiate between sessions. Here we have shown velocity, spin rate, arm acceleration, strike zone, ball trajectory, and arm path, fulfilling our system requirements. With a nice UI, we also fulfill our data visualization requirement, and being able to export our data to a save file fulfills our requirement to collect and store data.
Thank you so much for watching, and boiler up.